Year 11, today we're looking at the trig functions y is equal to sine theta and y is equal to cos theta. So just take a moment, please, to set up your theory book with that heading, and it will also be worthwhile for you just to sketch that unit circle again. You're going to need that. Now that you've set up your unit circle, let's have a look at what we're going to do. So we're basically going to go from the unit circle, and we're going to plot key points onto a Cartesian plane. So we're going to, first of all, focus on the graph of sine theta. So we're going to take all the y values of the points on the unit circle, and we're going to substitute it on the y-axis of our graph. And on the x-axis, we are going to plot the corresponding angle. So draw a little Cartesian plane, just a nice long x-axis there, and we're going to label it y and x. So make your x-axis long. Okay. Right, so we are now going to put down our key angles first, just roughly, because remember, you're always just sketching in methods. So that's my 90, 180, 270 and 360. So actually we should be talking in terms of radians rather. So pi on 2, pi, 3 pi on 2 and 2 pi. All right, so we're going to take our first angle, which is 0. And you can see the y value there, the yellow that you see is 0 as well. So that's our first point on our graph. When our angle is 0, our y value is 0. Next point will be on the 90-degree side, the pi on 2. When the angle is pi on 2, my y is 1. Right, so I'm just going to put a 1 over here. So when my angle is pi on 2, my y is 1. I'm just going to put a dot point over there. Next angle is 180 or pi, and my y value is back to 0. So I'm on my x-axis there. Going down to my 270 at 3 pi on 2, my y is -1, -1. So I just follow it, sort of have a scale going. And then back to 360, where my y value is back to 0. Right, and now you're just going to connect the dots, and what you're seeing in front of you now is called the sine graph. The sine graph. And there we go. And then that's one full complete revolution from 0 to 360. Now we can move to the left as well. So at the moment on the right-hand side, we went in a anti-clockwise direction. We can also go in a clockwise direction. So I'm just going to set up my scale again. You do the same. All right, so we've got it 90, -90, -180, -270, -360, and moving in a clockwise direction now on my unit circle, starting from 0, moving clockwise, -90, my y value is -1. Right, going to 180, my y value is 0. All the way around to the top there at -270, my y value is 1. And then back to 360 where my y value is 0. So we can move backwards as well. And that will give us our continuous sine graph that you see over there. So it's not very neat at all. And remember, the expectation for you is never to pick up a ruler and get a perfect scale going. It's just a sketch graph that you see. And there you go. This is called my sine graph, like that. So underneath this, I want you now on your own, see if you can generate the cos graph. So set it up, track now the x coordinate of the points, and put that on the y-axis versus the corresponding angle that you see. See how you go. Plot the video, stop the video and see how you go. All right, did you get something like that? That is my cos graph. So you'll see that for your first point, when my angle is 0, my y value is 1. At 90 degrees, my x value of the point is 0. At 180, my x value is -1. At 270, my x value is 0. And back to 360, I'm back to 1. So that's moving in an anti-clockwise direction. So if you move in a clockwise direction, you generate the graph on the left-hand side. So really important here, Levin, that you know the general shape of these graphs, and that you can sketch it and you understand what you're doing. Right, so this shows the link between the unit circle and the actual graphs. Let's have a look at the note over here. This is really, really important, and I actually just want you to take a moment to write that down, please. Have a good look at the sine and the cos graph. And you can see the shape or the pattern is really the same. So the difference between that sine and cos is that cos is just a sine theta graph that's been moved 90 degrees to the left. So imagine yourself grabbing the top point over here and then just moving that 90 degrees to the left. As if you shift it, we call it a phase shift. And if you do that, what you have is the cos graph. The other very, very important point that I want to show you is the one here in green, because this is going to help you to interpret graphs. It says cos theta starts at a maximum point. So the maximum point, so it starts at that 1, the cos theta. But if you look at the sine theta, it starts at a minimum point, so at that 0. And remember, we are going to look at transformations as well, where the graph moves all over on the Cartesian plane. But that's a really key thing to look at. Does the graph start at 0, at an equilibrium point, or does the graph start at a maximum point? So that's how you would be able to differentiate between a sine graph and a cos graph. I also want you, please, to write this table down in your book that you see over here. It's just a summary of the above graphs. It's also getting used to new terminology that we use. So make sure you copy that down, please. So again, we just talk about the domain and range of the graphs. For the domain for both graphs, you can see any value on the x-axis is valid. So x is an element of the real values and x is an element of the real values for both graphs. The range oscillates between a maximum and a minimum. The range goes from -1 to 1, and both of these points are included, so square brackets. And the period is the length of one complete cycle. So the period is 360 or 2 pi. Amplitude is what we call the maximum distance from the equilibrium. In this case, the equilibrium is the x-axis. So the amplitude is the maximum distance either going up or down, and that is 1. So familiarize yourself with this, with the terminology, please. And then this simulation down here, I want you please to open it up and play around with what you see. So switch between angles, degrees and radians, showing the quadrants, not showing the quadrants. It's a really good activity just to understand and see what you're looking at. All right, so this is the first short little lesson on trig graph, looking at our most basic sine and cos graph. Next lesson, we'll be moving on to transformations.